Dear viewers, welcome to another video in the series of control charts. As part of the control chart series, we have seen introduction to control charts, different types of control charts depending upon the data type and scenarios. We have seen about individual moving range chart, ZMR chart, X bar R chart, X bar S chart on the continuous data or variable data side. And on the attribute data side, we have seen P chart, NP chart, U chart, and C chart. In today's video, we will understand how Minitab can be used to plot a particular metric control chart in multiple stages. Let's get into the video. As I was explaining, control charts are graphical representation to understand how close is your data point towards the central tendency and what is the variation within the data point. So that's what we are using control chart for, to measure the performance of your metric with respect to central tendency and also how much is the variation in the data. Generally, when we take up a continuous improvement project, we use control charts in the define phase and measure phase to showcase the baseline data to show how a particular metric is performing. And we will also use the control chart during the improve and control phase to show how this particular metric has resulted or improved after the continuous improvement project. For example, in this case, I have a call duration project. So in a contact center, call duration is high. We need to complete the calls faster. The call duration central tendency should be reduced. At the same time, the variation in the call duration should also be reduced. So that is the purpose of this project. So there is a call duration before data and call duration after data. So generally what we do, we click on stats, we go to control charts for variable data collected in the form one after the other. So call duration before. So this is the control chart. Let me make the changes. Okay, so here is the control chart. So this control chart tells us, okay, this data in terms of its moving range, there is one data point which is having some issue. Otherwise, this data is pretty much stable. So with this, I can move on. And now what will happen? I will also plot the same control charts for after data to showcase the improvement in the project. This is in the improve and control phase of the project. So the X bar is 5.028 in the once the project is completed, and the X bar here is 7.079. So obviously the average of the call duration is reduced and the standard deviation also reduced. And how we can measure that? We can measure that with the help of the control limits, because control limits is indirectly the amount of variation in the process, and the control limits, whether it is narrow or broader, that also we'll be able to understand. But these are two different graphs. We need to put them side by side to understand about this. But what Minitab gives us as an option is, Minitab gives us an option of plotting these two charts in the same layout and comparing them next to each other, and that is what we say applying stage as a parameter when you draw your Minitab control charts. So here the same data, call duration before, call duration after, I have put it in a different layout. So what I have done, I have put the metric in one particular column, which is C5, and in C4 I have put before and after as a stage. That means the before data is up to this point and after data is up to this point. So now what I do, I click on stats, I click on control charts, and in control chart I select control charts for individual data. I select the data which is called duration. I select this data. I go to IMR chart options, and here there is a tab called stage. I click on stage, and here I select stage as one of my graph parameters. So this is where I'm going to select stage, and now I click OK, and I click OK. So now what you will be able to see is, you will be able to see the control chart for before and control chart for after, and it is very clearly evident that there is a significant reduction in the central line, or in other words, the central tendency of my call duration, and there is also a significant reduction in the control limits, the width of the control limit in my after process. So what happened? I can very clearly graphically explain to my stakeholders that I was successfully able to reduce the central tendency of the process, that is called duration, and I was also able to reduce the variation, and both are coming out in the same graph very clearly with respect to time. So we are able to measure variation, or we are able to compare variation, central tendency, and both with respect to time. If at all I would have used a histogram or I would have used a box plot to show the same information, I could still show the reduction in the central tendency, I could still show the reduction in the variation in the process, but I'll not be able to show chronologically that the process is also stable. So what control chart brings to the table, which histogram or box plot is not able to bring to table, is you can compare central tendency, you can compare variation, but you can also compare stability of the process in the same graph. So that is the benefit of using stages while plotting control charts. Just to show you some more some more different options that you have in this particular option that you have, bringing in stages into control charts. I have another project where the intention is the average of the process is still good, only I need to reduce variation. So outer diameter of a drilling process, so or a grinding process, and I need to reduce the variation. So what we do, same chart. So I click on stat, I go to control charts for individual data, I select IMR, and here I select the metric. Here will be outer diameter. Just a minute, sorry, the metric here is going to be inner diameter, and the stage will be stage 1. So I select this and I click OK, and now I click OK. Now what you will be able to see in this graph is the intention of the project is not to move the central tendency. The central tendency more or less remained where it was. The central tendency more or less remained where it was. But what we are able to achieve is we are able to achieve, or we are able to reduce variation in the process as a result of this project. There are certain special causes in terms of test number 4. So if at all you want to know what is test number 4, what we can do is we can minimize this graph. We can press Ctrl E. We can go to IMR options, and in IMR options you can click on test 1, 2, 3, 4. So 14 data points in a row alternating up and down. So there are 14 data points in a row alternating up and down. That is why there were red dots in this particular graph. We need to understand why is that, and see if at all there is any kind of toggling effect in this particular process. Otherwise, from a variation perspective, we are able to control our variation. This is how we study this. Even when you are doing DOE, let's say if there are multiple design of experiments being done and you want to understand the design of experiment results, there are many graphs available, but still we can use one more option to see how the central tendency is moving and how the variation is getting controlled or increased. So what I can do is I have done 4 stages of DOE, 4 different experiments. So here, to improve the bond strength of a particular process in a adhesive process, bond strength need to be measured. So I go to stages, and in stages, I go to stages, and in stages I select the DOE stages, different experiments that I have done. I click OK, and then I click OK, and when I click OK, now what you see is there are 4 different experiments being done: stage 1, stage 2, stage 3, stage 4. In all these stages, the average is more or less same, but the variation is differing. There is difference in the variation. So that is something that we can study and analyze what is happening in each of this experiment and how things are changing when we do this experiment. What is the reason for the amount of variation? Friends, I hope this video was useful for you to understand how we can bring in stage as one of the graph parameters when we are performing control charts, and by bringing in stage, what kind of inference that we will be able to make. I hope this video will be useful. For more videos on control charts, Lean Six Sigma tools and techniques, Minitab exercises, please subscribe our channel. Thanks for your time.